This is Buzz, and I'm back with episode number 24 of AirWaves, and I have here with me a NANO VNA. Many of you have probably seen this on YouTube videos and advertised online like Amazon and eBay. And I had watched a few of the videos and kind of intrigued me. And so I thought, well, I'm gonna get one and check them out because they're relatively inexpensive. I paid $55 for this one here. It comes with the VNA itself, plus it comes with these two patch cables, which have male SMA plugs on each end. It also comes with a female to female adapter for these cables. You'll see how that comes in to play. And then you have these three caps here that go on the outputs of the VNA, and they are for calibration purposes. And there are three. There's one which is an open, one which is a shorted or closed, and then one which is a load, which is a 50 ohm simulated load. First of all, I want to talk about the negatives up front. Okay, this is actually the second unit that I've had. I ordered the first one and it didn't work right out of the box. It just got worse. I played with it for 2 days. The first day it seemed kind of iffy. I thought, well, maybe it's operator error, but by the second day it was just really erratic behavior. I had to constantly turn it on and off to reset it. This one, I've run it through a few tests, and this one seems to be pretty good so far. I haven't noticed any problems with this. And in watching other videos, I've noticed that seems to be a common occurrence. People are having to get 2 and even 3 versions before they finally get one that works correctly. And that may speak more to quality control than anything. I don't know, but also in watching the videos, people seem to be pretty much of a mind that once you find a good one, then they work pretty good. A couple of other things too that I noticed that kind of bother me. First of all, if you can see this thing does not have an actual box to it. It's basically 2 metal plates with circuit board in between the plates and the display screen. Okay, so that's, to me, that's asking for trouble. It'd be very easy for something to fall down in there and short something out, also dust to get in there. I don't understand why they chose to do it this way. I mean, I can't really save that much money, I wouldn't think, to put a full case on there, but that is the way they're made. Another thing I noticed in almost all the videos I watched, you see this little tab right here, bluish green tab. That's a screen protector, one of those vinyl decals, that they'll put on screens for phones and anything with a display when they're new. Yeah, this tab right here. Now, the only way to get that off is to unscrew. There's a screw in each corner here on this faceplate. You have to unscrew those and take the faceplate off to peel that off. Again, I don't understand why they did it that way. And as I saw a lot of videos, people, I don't know if they didn't know to take them off or they decided just to leave it on there to protect the screen. But most of the ones I saw, that film was still on the display. On my first one, I took it off, and I will take this one off eventually, but I just wanted you to see how it comes. Okay. Another issue with these is, of course, it's a very small screen. It's a 2.8-inch screen, and if you're visually challenged like many of us are, it can be difficult to see what's going on. And I'm going to go ahead and turn it on here. There's a boot up screen, and it comes up. Now, when it comes up, you'll see lots of different colored lines on there. And as you get into the operation of it, you learn, and that brings me to another problem I have with this. This comes with no directions whatsoever. Okay, basically I had to go online, watch videos, and see how other people were doing it. And there is a website, and when it boots up it gives you an address, and there is also software associated with the VNA. And I'm going to tell you right now, you're better off using the software because it's much easier to see what you're looking at. And I'm going to get into that later on in the video. The software program that they recommend, and you cannot download the program, by the way, you can only use it online. There's a USB cable came with this, and you have to use the program online. You can't download it onto your computer, which I find that kind of irritating as well. But I found a third-party software program that I like better. Oh, and also, when I did connect the device, and maybe it's because there was something wrong with it, it would not work with the recommended software. It would not connect. I kept getting a connect error. Now the third-party program, it would connect, and I was able to see the data on the program. So we'll get into that later on and see what happens with this one. Those are basically the negatives. But if you can get it to work, for a $55 price point, it's a pretty valuable tool. So you'll see also in the end here that blue LED. That means that it's on. And when you're charging the device, it will flash blue like that is right there now, which I guess means it's using power. I don't know. I don't remember seeing that on the other device, but again, it wasn't working properly. So one thing though that seems to be unanimous among everyone is that you need to calibrate the unit before you use it, and it's a relatively simple process, and that's where these caps here and the SMA jumper cable come into play. So I'm going to zoom in on this and I'll go through that process with you. Okay, here we are zoomed in on the display, and was talking about the calibration of the unit. But first thing, what I would do is, there are so many different colored lines on here, it gets kind of confusing. And this video, really, we're going to focus in on checking the SWR for antennas. So anytime you press the screen, it's going to bring up this here. Now you can also go through this using this little jog wheel up here. But again, that's something that I find cumbersome. So I go ahead and I use the stylus. But what I would do, we click display there at the top. Okay. And then we push trace. Now you'll notice all these colored bands. Each one of those, there's trace 1, 2, 3, 4, is all these different colored bands you see on here. What I do is I turn off everything but the top trace, and just by pressing that turns them off. So now all we have is the yellow trace. You see it at the top of the screen. Okay, and I'm going backwards here, and we're back to the main screen. And what I'm going to do now is select Cal, which is calibrate. And up here you have to hit calibrate again. And these boxes say open, short, load, and those are the only three that we're going to be concerned with, because in checking standing wave, and for most functions that you would use this for a ham radio, those are really the only three that you would be concerned with. So what you have to do, it says the first one here is open, and again there's no directions as to which one of these is which, but if you have any experience with radios, electronics in general, an open means it's an open circuit. But basically, if you look in the cap, you'll see there's no center pin like you would normally see on a male plug of a coax cable, like a PL259 type. So you screw that on there, most people say put one of these cables on there, because when you test whatever antenna you're going to be testing, this wire is going to be in the circuit, so it's best to have that in there. But for demonstration purposes, I'm just going to show you how this is done. But you put your open on there first, and once it's in there, then you press open and it automatically moves down. Now the green bar is over short. So you take the open cap off, and the one thing way you can distinguish the others is one of these has a silver bottom on it. That's the load one. So we know that was the open, so this one has to be the short, and it has a pin in the center and it's connected to the outer casing, so it's shorted. So we put that on there, and then we press short, and now it moves to load. The green bar is over load. So we only have one cap left, and that's the 50 ohm load that simulates an antenna. So we put that on there, and we push load. Okay, now it automatically goes down to the next one, but we're not going to go through the final two steps because they're not necessary. So what you do is you go back down here and you push done, and when you push done, it comes up and it opens up these places where you can store your settings. Now I'm not going to store this one because I've already gone through the calibration and set it up, but you would press it in one of these and it will remember your calibration that you did. And what you have to do, according to what I've read online, is every time you change the frequency span of what you're going to test, you should calibrate it with that band in mind. And it's really too tedious to watch and see this on this small screen. So what I'm going to do is I'm going to connect this device up to a computer for the rest of this video and show you how we can check the SWR. We're connected now to the program NANO VNA Saver, and this is the third-party program I was telling you about earlier, which is a downloadable program. You can download it onto your PC and then start it up. Whereas the recommended program that came with the VNA, when you boot it up, it gives you a URL to go to. That is a web-based program, which I don't really care for. I'd rather be able to download the program on my PC and not have to worry about having an internet connection. And I couldn't get it to connect anyway. So we're going to use this third-party program, and I will give you the URL in the description below so you can check it out. And I prefer this over using the touch screen on the VNA, just obviously because of size. And if your eyesight's not quite what it used to be, then you're definitely going to like this program better. Oh, and another thing I wanted to mention that I neglected to tell you earlier is the VNA, you may have noticed, has two ports on it. They're called channels, channel 0 and channel 1. Channel 0 is a transmit channel, channel 1 is the receive channel. The only channel that basically you will need for most purposes, if you're using it for ham radio, is channel 0, the transmit channel, and that's also the channel that I use to do the calibration of the VNA. Down here you'll notice that when I connected it, scanned and found the VNA on COM port 7. So I'm going to say connect VNA, and now it says 100% is checked. And you'll remember I had set up a sweep control of 130 megahertz to 160 megahertz, so I could check this rubber ducky antenna that's made for 2 meters. And so it shows you it has a center frequency here of 145 megahertz, which puts us there in the 2 meter band. And so anyway, it scanned the antenna, and you'll see over here on the right, it gives you a graphical display of the SWR. And across the bottom here, the graph, it starts at 130 megahertz and goes on over to 160 megahertz. And the center frequency 145, which is what our main concern is. I can click on that, And you can see that that's a pretty level plane right there. But it displays the information up here. It says I'm at 144.7 megahertz. Gives the impedance, and then the VSWR of 2.212, which is not great, but then, you know, it's a rubber ducky antenna, so that's what you get. To me, this is a more user-friendly way to use the VNA, to use this software program. So just for kicks here, I've got 3 different rubber duckies, and this one I've got connected first. This is the shortest one of the bunch. This one here is a little slightly larger. So we were getting a 2.212 at the center frequency with that first antenna. So we'll do another sweep here and see what this one comes up with. Now this is showing a 2.058, which is slightly better at the center frequency, 144.7 megahertz. So I've got a third rubber ducky antenna. This is actually a Nagoya, longer antenna. This is a 15-inch Nagoya NA-771. So we'll connect that one now and see what it thinks about that. Hit the sweep button. Alright, so we got something different going on here. Now you see, again, the center frequency. This has been the best yet, a 1.856 VSWR. Still not great, but again, like I say, we're dealing with a rubber ducky antenna. But you'll notice over here on the graph, if I click down here, it's actually a little more resonant at 135 megahertz, which is interesting. But this is a dual band antenna, so I suspect if we were to broaden this out, and I'm not sure, I haven't tried this. I'm going to see if this will override the settings on the VNA. Okay, and do a sweep and see what happens here. It did change it, so that's nice. So you see over here on the right, we've got a whole different thing going on here, and you see the dual band possibilities here. So I'm moving this little red triangle down to the low spot. So this is saying at 165.2 megahertz, that's a VSWR of 1.463. And then it rises up here in the middle, and then we'll run it over here. We're getting in the 70 centimeter band. We got a 1.475, basically the same, at 434 megahertz. So you can see on this antenna, it does in fact have dual band capability, and they're pretty much about the same. Let's go back and look at the shorter rubber duckies again and see how they compare. That's what I like about this VNA. I mean, there's just so many things you can check. If you're a person who likes to build your own antennas, and I do like to do that sometimes, this is a great way to check out the resonant frequencies of your antenna. And at $55 is cheap. Like I say, if you can get one that works like it's supposed to, then it's a great thing. So I've got the first rubber ducky, the shortest one of the 3, and we'll do a sweep on it. Now you'll see this too has the dual band. If you go down here, let's see, let's get about 100. There's 146 megahertz. It's pretty flat in there. So that's a 2.2 SWR. And if I go over here into the 70 centimeter, yeah, again, it's flat over there, 1.923. So it actually has slightly better standing wave ratio on 70 centimeters than it does the 2 meter band. Okay, that was the shortest, and now we'll do the next one, which is slightly longer. Of course, you want to make sure you have good connections at your VNA and at the base of the antenna. So we'll do a sweep here on this one. Again, we're checking 130 megahertz to 450 megahertz, so we get both the 2 meter and 70 centimeter bands. And this is an interesting antenna here. You'll notice here at 450 megahertz, it's pretty good, 1.168. That's pretty low. But I notice here also, it looks like in the 220. Yeah, on the 220 megahertz, which is another band, it's got a VSWR of 1.334, and it's actually not as efficient when you get up here in the 2 meter band. You know, it's just under 2.0. So anyway, we've tested 3 different rubber ducky antennas here, and we discovered that one of the 3 actually has some pretty decent 220 megahertz capabilities with it there. So as you can see, this program here, I believe, makes this VNA a much more usable tool. And there are ways you can save your settings on here, and the fact that you can actually go in here and change settings on the screen, and it changes it on the VNA itself, makes it really useful. As you'll remember in an earlier video too, I'd showed you that I had changed to just one marker, and that's reflected here. You can activate these other markers which measure, you'll see here, this is marker 1, marker 2, and you can actually, marker 3, you can be checking different aspects of the antenna. Like down here you've got your polar plot. And this is the Smith chart, by the way, up here, if you're familiar with that. Again, the bad things about the VNA, as I discussed earlier, I had the first one that came was defective. I had to return it. They sent me a new one, and this one seems to be working correctly. But in watching other videos on YouTube, that seems to be a common issue. You know, you keep your fingers crossed that you get a good one. Also, as I mentioned, the screen protecting film that's on there, the only way to get that off is to actually remove the faceplate of the VNA, which I think is kind of ridiculous. And also the sides of the VNA are open. There is no case. There's only a front and back plate to this. I guess that's a cost-saving thing, but again, I mean, how much more could it cost to put a complete case around it? I think that opens it up to getting water in it and dust, and you know, and who knows what else in there that could possibly damage it. And the fact too that again it would not connect to the program that it's designed to connect to, but that could be because the first unit was defective. I'll go back and take another look at that, and maybe in a future video give you an update on that. But this is the NANO VNA. Like I said, I paid $55 for it from Amazon. You can see other videos on YouTube, people getting mixed results with it, and I say, you know, for $55, what have you got to lose? If you got one that works, it is a useful tool, even with all of its drawbacks. So I'm interested to see your thoughts on it. If you would, post them below and tell me what you think about this, and maybe if there's more information you'd like to see in a future video, you can put that down below too. But in the meantime, this has been episode number 24 of AirWaves. I'm Buzz Stone. I appreciate it if you'd subscribe to my channel. Also like the video and share it, and I'll see you down the dial.